we're starting the new topic today, which is expectations or mean. It's the same thing, standard deviation and variance. Now I'm going to write a few formulas we've already studied related to mean and standard deviation. So we've already discussed that when we have ungrouped data, then the mean is summation x upon n. This we know from O levels. And the standard deviation is the symbol for this is mostly this. Standard deviation is summation x squared upon n minus mean squared. This is the mean. Similarly, variance is, okay, there's supposed to be a square root here, sorry. Variance is square of the standard deviation. So it's the same thing, but without the square root. Next, we talk about grouped data. So again, from O levels, we already know that for group data, the mean is summation xf upon summation f. The standard deviation is summation x squared times f upon summation f minus mean squared, and with an under root sign. And similarly, the variance is same thing without the square. Similarly, we have discussed probability distribution. So in probability distribution, we don't call it mean anymore. It's now called expected value. Expected value. And that is equals to summation x times the probability. Because we have a probability distribution table now. The upper row is x, the lower row has the probabilities. So we multiply each data value with its probability. Okay. And then the standard deviation in this case is summation x squared times probability minus the expected value squared and square root of this. Similarly, variance is exactly the same except for the square root. Then the other day we studied binomial distribution. In binomial distribution, instead of mean, we say the expected value. And the formula for that is n times p times q. No, sorry, it's just np. And the standard deviation is square root npq. Similarly, the variance would be just npq. All these formulas that I've mentioned on the board are given in the formula sheet, in the formula document. in the statistics section. Okay. Now we're going to start the worksheet directly. Question number 1. A fair cubical die has faces number 111234 is thrown and the score is noted. Area A of the score of side equal to the score is calculated. The area A of a square of side equal to the score is calculated. So for example, when the score on the die is 3, the value of A is 9. So basically you're throwing a die and whatever is the top value, you square it and that's the score you move. Draw up a table to show probability distribution of A. Okay. So we have to draw probability distribution table of A, which is the score. So when you throw a die, you get a 1. So the area would be 1 square, which is 1. If you throw a dice and you get 2, so then the score is 4. You throw a die, if you get a 3, then the score is 9. Similarly, 16, 25, and 36. Okay, now we have to write the probabilities. This is X and this is probability of X. Okay, you get a score of 1 when you get a 1 because 1 squared is 1. And what is the probability of getting a 1 in this die? It's 3 upon 6. So the probability is 3 upon 6. Probability of getting a 4 is 1 by 6. Probability of getting a 4. You get a 4 when you throw a 2. So that's also 1 by 4. Then you get a score of 9 when you throw 3, and that's also 1 by, it's 6, not 4. You get a 16 when you throw a 4, so that's also 1 by 6. Oh, you never get a 25 and you never get a 36. I did not read the question properly. So you can't get a 5 by throwing this die and you can't get a 36 by throwing this die. So this is the probability distribution. You do not write this. Part 1 is done. Draw a table to show the probability distribution. Part 2, find the expected value of A and the variance of A. So expected values formula from probability distribution is summation X times probability. So it's going to be 1 times 3 by 6 plus 4 times 1 by 6 plus 9 times 1 by 6 plus 16 times 1 by 6, which gives 5.33. So the expected value of the event is 5.33 or the expected outcome. Okay. Now we have to find variance of A. So the formula for that is you do not square root for variance. It's going to be summation X squared times probability minus expected value squared. So it's going to be 1 squared times its probability plus 4 squared times its probability plus 9 squared times its probability plus 16 squared times its probability minus, use the unrounded off answer. I just have 5.33. I'm using that. You'll use the entire calculator display. And this should get you the answer. 30.9 is the answer at the back.
ये कौन सा चैप्टर है?
Expectation means variance and standard deviation. ये हमने पहले किया हुआ है। प्रोबेबिलिटी डिस्ट्रीब्यूशन की एक्सपेक्टेड वैल्यू इस फॉर्मूला से निकलती है और वेरिएंस इस फॉर्मूला से निकलती है। यहाँ मैंने सारे फॉर्मूलाज लिखवाए हैं।
ठीक है मैम।
मीन का क्या फॉर्मूला है, स्टैंडर्ड डेविएशन का क्या फॉर्मूला है फॉर बोथ ग्रुप डेटा एंड अनग्रुप डेटा। फिर जब हमने प्रोबेबिलिटी डिस्ट्रीब्यूशन की थी उसकी एक्सपेक्टेड वैल्यू इन फॉर्मूला से निकलती थी और वेरिएंस और बायनोमियल डिस्ट्रीब्यूशन जो हमने अभी पढ़ी थी उसकी एक्सपेक्टेड वैल्यू होती है एनपी और स्टैंडर्ड डेविएशन होती है स्क्वायर रूट एनपी की। अब इस वर्कशीट में खाली expected value और variance और standard deviation के questions are related to all these distribution, probability distribution which we've already covered, binomial distribution which we've already covered, and simple grouped and ungrouped data. So the first question was from probability distribution, so we use the probability distribution formulas, and all these formulas are given in the formula sheet. Okay, question 2 is from a topic we've done in great detail. I don't think we should revisit that right now. ये हमने submissions वाला topic काफी डिटेल में किया था. I think it was the second or third topic I did with you guys. So इसको हम नहीं कर रहे. इसका part 2 is from normal distribution. Normal distribution तो हमने पढ़ी नहीं है. Part 1 को हमने एक पूरी वर्कशीट में बहुत डिटेल में बात कर ली है, तो यहाँ पे सबमिशन वाले केसेस हम दोबारा नहीं कर रहे. Refer to the old lecture if you've forgotten it. Okay, question 3. A discrete random variable x has the following probability distribution. So probability distribution is already given to you. Like in question number 1, we had to construct the table on our own. Here it's an easier version of that question where the probability distribution table is already given. Write down an equation satisfying A and B. So we know that in a probability distribution table, the sum of all the probabilities is going to be 1. So for part 1, that formula would be 0.3 plus A plus B plus 0.25 equals 1. It's going to be A plus B equals 0.45. Part 2, given that expected value is 4, find the values of A and B. Now, what's the formula for expected value in probability distribution? That is summation x times probability. So it's going to be 1 times 0.3 plus 3a plus 5b plus 7 times 0.25, and we're given the expected value, it is 4. So rearrange it and get the second equation. 3a plus 5b equals, when you simplify the constant and move it to the right hand side, you get 1.95. So now you have two simultaneous equations. This plus the one we got in part 1. Solve these two using elimination or substitution method and get the values of A and B. So A plus B is 0.45 and 3A plus 5B is 0.45. I am going to multiply the first equation with minus 3. So that becomes minus 3A minus 3B equals minus 1.35. And then we have 3A plus 5B equals 0.45. When we add, A gets eliminated. We have 2B here, and we have minus 0.6 here. Sorry, 3a plus 5b was equals to 1.95. This is 1.95. So that would be plus 0.6. So b would be equals to 0.6 divided by 2, 0.3. And now find a. A would be, use any one of the equations. I'm using this one, the first one. So a plus 0.3 is equals to 0.45. A equals 0.15. This is all of question number 3. Question 3. Oh, sorry, question 4. A box contains 10 pens, of which 3 are new. A random sample of 2 pens is taken. Show that the probability of getting exactly 1 new pen in the sample is 7 by 50. Okay, so there are 10 pens, 3 of which are new, and 2 pens are drawn. And you have to show that exactly one of the pen is new. So I am going to say that we're drawing 2 pens. Let's say the first one is old and the next one is new, or the first one is new and the second one is old. So out of the 10 pen, you draw 1 pen. Its probability of it being old would be 7 by 10 times, then getting the probability of getting a new pen would be 3 upon 9, or is plus probability of getting a new pen in the first draw would be 3 upon 10. Then probability of getting an old pen would be 7 upon 9. This would be equals to 7 by 15. Okay. Part 2. Construct a probability distribution table for the number of new pens in the sample. Okay, so it could be 0 new pens, 1 new pens, or 2 new pens. 2 pens are being drawn. Maybe you don't get any new pen, maybe you get 1 new pen, or maybe you get 2 new pens. Okay. We already know the probability of getting 2 new pens, that's 7 by 15. Now we have to find the probability that no new pens are drawn. So I'm going to write this as X. This is probability X equals X. So probability X equals 0. No new pen is drawn. So that would be the first pen is old and the second pen is old as well. So that is going to be 7 by 10 times 6 by 9, which is equals to 7 by 15. Acha, sorry, this was supposed to be 7 by 15. That one new pen is drawn. मैंने गलत column में लिख लिया. This was 7 by 15. We haven't found the probability that both the pens are new. Okay, so the answer for this is also 7 by 15. So we write 7 by 15 here. Then the probability that both pens are new. So that would be 7 by 10 into sorry, both pens are new, not old. So new and new. So first probability of getting a new pen would be 3 upon 10. And then the second probability of getting a new pen again would be 2 by 9, which gives 1 by 15. So we have constructed the probability distribution table. Part 2, part 3, calculate the expected number of new pens in the sample. So we have to find expected value. What is the expected values formula and probability distribution? It's just summation x times pi. 0 times 7 by 15 plus 1 times 7 by 15 plus 2 times 1 by 15. Which is going to be 3 by 5. Next question. A computer generates random numbers which are either 0 or 2. On a particular occasion, it generates a set of numbers which consists of 23 zeros and 17 twos. So, if I make a table, a simple table, not a probability table, a frequency table, in fact, this is a frequency table. So then the frequency of getting a 0 is 23 and there are 17 twos. So this is X and this is F. Okay, find the mean and variance of this set of 40 numbers. So the formula for mean is of group data is summation of Fx upon summation F. This is the mean. Let's find that out. It's going to be 0 times 23 plus 2 times 17 upon the total value, which is 23 plus 17. 40 actually. So 40. In the denominator, which gives 0.85. Now we have to find the variance. So the formula for variance is sigma squared, which is summation x squared f upon summation f minus mean squared. So it's going to be 0 squared times 23 plus 2 squared times 17 upon summation of f, which is 40, minus mean squared, which is 0.85 squared. We do not square root the whole thing because it is variance and not standard deviation. So all of this gives 0.9775. Question 6. A discrete random variable x has the following probability distribution. Find the value of c. So we know that this sum is going to be equals to 1. 3c plus 4c plus 5c plus 6c equals 1. So c would come out to be, this would be 18c equals 1. C equals 1 by 18. Part 2 says find expected value and the variance. Let me redraw the probability distribution table, this time by substituting 1 by 18 in place of C. So for 1, for 2, for 3, for 4, the probabilities are 3 by 18, 4 by 18, 5 by 18, and 6 by 18. So the formula for expected value is summation x times probability. So 1 times 3 by 18 plus 2 times 4 by 18 plus 3 times 5 by 18 plus 4 times 6 by 18, which gives 25 by 9. Next is the variance. And the formula for variance is summation x squared probability minus summation x squared, sorry, expected value squared. So that's going to be 1 squared 3 by 18 plus 2 squared 4 by 18 plus 3 squared 5 by 18 plus 4 squared 6 by 18 upon, there's no upon in this case, minus expected values squared 95 by 81. Would be the answer. Part 3, probability. We have to find the probability x is greater than the expected value. And what was the expected value? Probability x is greater than the expected value is this 25 by 9, which is what in decimals? 2.77. So that means it's the probability of getting a 3 or probability of getting a 4. X equals 3 and x equals 4. So that would be probability of getting a 3 is 5 by 18 plus probability of getting a 4 is 6 by 18. 11 by 18. Let's see if we can make time for one more question. Question 7. Two cricket teams kept records of the numbers of runs scored by their team in 8 matches. The scores are shown in the following table. So we have the score for team A in the 8 matches, 150, 220, and so on. So this is ungrouped data. And similarly, we have score of for team B in the 8 matches. Part 1 says find the mean and standard deviation of score for team A. So we're going to use the ungrouped data formula. For mean, it's summation x upon n. So n is 8, and for summation x, just add all the values. I'm going to write dot 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 and plus 57. And now I'm going to write the answer, which is 138.75. That's the mean score for team A. And similarly, now the standard deviation for ungrouped data, which is summation x squared upon n minus mean squared and square root of all of this. So it's going to be 150 square plus 220 square all the way till 57 squared. Divide this with 8, then minus 138.75 squared, and that under root of all of this. Of course, you cannot write dot dot in the exam. You must write everything. And then the answer written at the back for this is 83.1. So the standard deviation is 83.1. Remember, in standard deviation, you square root, and in variance, you do not square root. Okay. Next part is the mean and standard deviation for team B is 150.75 and 29.63. State with the reason which team has more consistent score. So consistency is dependent on standard deviation. Bigger the standard deviation, less consistent is the data. And similarly, smaller the standard deviation, more consistent. So we're looking for the more consistent data. So that means we need the one with smaller standard deviation. So for A, this is the standard deviation. And for B, team B, this is the standard deviation. So B has a smaller standard deviation. That means B's data values are more consistent. Yes, so you're going to write team B as its small standard deviation is smaller. Team B because standard deviation is smaller. Okay. I think that is enough for today. We won't be able to squeeze in one more question in the remaining time. I will see you guys tomorrow, inshallah. Allah Hafiz.